So in our last class, we stopped at question number 12. And the question states that we are to look at machine as a topic, which I dropped the link to the class for you guys. I believe everybody has watched that. So we are going to question number 12. And question number 12 states that which of the following could be effectively used to reduce friction? A. Petrol, B. Kerosene, C. Grease, D. Water. Absolutely, you agree with me that this particular topic is strictly under friction. So we are going to start by looking at friction as a topic on its own. So the topic is friction. Now, when you talk about friction, please can you guys still hear me? Because I'm no longer seeing you people again. So
Yes, sir.
all right, thank you. Now, when you talk about friction, what exactly examiner wants you to know, or what exactly are they trying to test as far as this topic is concerned? Number one is that they want to test you if you understand the possible definition or rules or law or condition that bind friction. When you talk about friction, what are the things that friction depends on? What are the factors that determine friction of a body? What are the types of frictions that we have? This is the first thing that examiner want to test. Then, if they are able to test this, they also want to test if you understand the point where friction is an advantage and the point where friction is a disadvantage. And they want to test if you can reduce the level of friction that we have in a system. And lastly, examiner want to test you if you can carry out calculations that involves what? Friction. Those are the things that examiners want to know. And that's what they want to test you on. Alright? So we're going to start now by summarizing this topic in line with all this that we have mentioned. And at the end of the class, I'm going to link the full lecture on friction. I'm going to link it to this video so that you can watch it and then understand more about friction, either the one that you are going to be using now or that you might probably use in future. So without wasting any much of our time, what is friction? When you say friction, the first thing that everybody understands frictions to be is that it is a contact force. Everybody understands friction to be a contact force. When you say a force is a contact force, what you are saying is that that force cannot occur except there is what? There is a contact between two things. When there is contact between two things, the force that occurs there is called a contact force. For example, if I push you, if you push something, your hand must be in contact with what you want to push. Without your hand in contact with what you want to push, there's no way you can push. When you want to pull, your hand must be in contact with that thing that you want to pull. If your hand is not in contact, there's no way you can pull. Also, frictional force is also an example of a contact force. Let's take for instance, when you walk and you did not fall down, what prevents you from falling down is because your foot, that is your leg, is in contact with the floor. When your leg is in contact with the floor and you start moving, by the time you start moving, because of the contact between your leg and the floor, a force that is opposing your motion is going to arise because of that contact and that movement. That force is what we call a frictional force. You see now that it is an example of a contact force, and it opposes what? Motion of an object. Am I making sense? Are you there? Are you guys getting me?
Yes, sir.
Okay, if you know you're in a quiet place, that the place you are is very quiet, you can unmute your mic so that when I ask question, you can quickly respond, so that I know that you guys can hear me and you are following. All right, so without wasting much of our time, we have understand the first thing about friction, that it is a contact force. Now, another thing you need to understand about it is that, okay, somebody is asking us if we can continue using the Google Meet. What's the challenge that you are having? You can unmute your mic, Chioma. Is Chioma there? Hello? The person that asked the question, now can we continue using Google Meet? Can you unmute your mic and tell me reason why? What's your challenge? Is it that the person don't know how to unmute your mic or what? Okay, class, do you prefer Google Meet to this? I need to ask. You can unmute your mic. Can somebody hear me?
Yes, sir.
Yes.
Are you okay with this or Google Meet?
This one is fine. It's fine.
Okay, this one is okay, right?
Yes, sir.
Yes, sir.
Sir, anyone is preferable.
Okay. Okay, if you're not hearing anything at all as far as Chioma is concerned, then the problem should be from your network, not from the medium that we are using, because others can hear me. So you can check your network. Thank you. Okay, so back to what I'm saying. So contact force. When you say contact force, I've explained what it is, and I've given you
Sir,
example of it.
sir, I'm sorry for interrupting. But sir, after the class is over, can we watch the video again? Is it
Yeah,
possible?
yes, exactly. You can watch it after the class.
Okay.
Okay, so let me quickly summarize the properties of a frictional force. So when you say frictional force, number one, you should know that it is a contact force. Number two, know that it opposes the motion of an object. The motion of an object. Friction, friction between two rough surfaces. Friction between two rough surfaces is greater than that between two smooth surfaces. Two smooth surfaces. Another one is that friction force depends on type of material. Frictional force depends on type of material. On types of materials. Also note that frictional force is proportional. Frictional force is proportional to normal reaction. Frictional force is proportional to normal reaction. When I say normal reaction, you are talking about the weight of the body in contact. Frictional force is proportional to the weight of the body in contact. Frictional force is proportional to the weight of the body in contact.
Okay.
Also, sliding friction, or what we call kinetic friction, is the friction between two moving subjects. When you say sliding friction, sliding friction is the friction between two moving bodies. The friction between two moving bodies. So do we get this now? So these are some of the properties of friction. Now, why am I listing all these things out for you like this? You see, the first part of examiner testing you on friction is that they want to know if you understand it very well. And by understanding it, it means you know the definition and you know what it depends on and what it doesn't depend on. Let me quickly summarize some for you. When you say the frictional force between rough surfaces, it is what? It is greater than that of between two smooth surfaces. When you have a surface that is perfectly smooth, the frictional force between such surface is going to be zero. Because when you talk about coefficient of friction, this coefficient of friction is what we used to know, what is it called? We use it to determine the rate of friction between two surfaces. If I have a surface like this, and here is another surface in contact with it, are you getting it now? So if you want to know what is the properties of this friction, is it going to be high, is it going to be low, you use the coefficient of friction to determine that. And coefficient of friction ranges between 0 and 1. There is no way you are going to calculate coefficient of friction that you are going to add a negative. I want you to keep noting this now. You can't look for coefficient of friction and get negative. You can't look for coefficient of friction and get a number greater than 1. It's just like probability. Your result is in between 0 and 1. So if you have that, the body is perfectly smooth. That is, the two surfaces in contact, if you have it that they are perfectly smooth, then the coefficient of friction is going to be 0. That is, the frictional force between such bodies is going to be 0. And if you have it that it is perfectly rough, that is, it is 100% rough surface, that means that the coefficient of friction is going to be 1. So if it's not perfectly rough and not perfectly smooth, your answer will be dangling between 0 and 1. Do you guys understand this now? Hello? Are we there?
Yes, sir.
Yes, sir.
So do you get the explanation now?
No, sir. Please go over it again.
If you have is when you talk about coefficient of friction is the ratio of force to normal reaction. That is the ratio of frictional force to the weight of the given body. So this factor is what we use to determine the rates at which the frictional force is on a particular body. Is it very high or very low? This value ranges between 0 and 1. If the surface in contact, when two surfaces are in contact, there is frictional force between them. If the two surfaces in contact, if they are perfectly smooth, that is, they are 100% smooth, the coefficient of friction there is going to be 0. If coefficient of friction is 0, that means your frictional force is going to be 0. For you to get what I'm saying, let me clean the board and give you this particular instance. so that you understand this before we move on. Okay. All right. So look up now. Let's take for instance that this is a table and you have an object on this table. Can you see the object? Let's say the mass of this object is 10 kilogram. If the mass of the object is 10 kilogram, the weight of this object is going to act in downward direction on this particular platform. Let's say the weight is what? Mg, right? So let's say gravity is 10 at this point. Okay, let me just say gravity is 9.8. If gravity is 9.8, 9.8 times 10, that will give us 98 Newton. That is the weight of this body. Now, I want to know the nature of the frictional force on this surface. Frictional force is given as mu, which is coefficient of friction, multiplied by the weight, which is mg. Now, if this surface, if it is perfectly smooth, that is the two surfaces in contact, if they are smooth, for smooth surface, you have that coefficient of friction is equal to 0. Are you following?
Yes, sir.
If coefficient of friction is 0, then it means that frictional force between those two surfaces is also going to be 0, because 0 multiplied by 98 is going to give us 0. So frictional force between two smooth surfaces is 0. Let's say the surface is perfectly rough, that is 100% rough. The coefficient of friction is going to be 1. If coefficient of friction is 1, then we are going to have that the frictional force is going to be 1 multiplied by 98, and that will be 98 Newton. If it is not 100% rough or 100% smooth, that is, it's in between smoothness and roughness. Let's take for instance that coefficient of friction is 0.5. That is, it's not perfectly smooth and it's not what? Perfectly rough. So it's within that kind of 0.5, that is in between, perfectly in between 0 and 1. What will be the what? Frictional force. So that will be 0.5, which is 1 over 2, multiplied by what? 98. And that will give us 49 Newton. Are you seeing it now? So any other value less than 1, I'll be having F to be less than what? 98. So that's why I said the coefficient of the frictional force is going to be maximum when the surface is 100% rough, and it's going to be what? Minimum, that is 0, when the surface is perfectly smooth. And that's why we said coefficient of friction lies between 0 and 1. So it's not possible for you to have your coefficient of friction to be negative. So when you calculate and you're having negative answer for your coefficient of friction, then something is wrong somewhere. If you calculate and you're having 1 and you're having negative rather, it's wrong. If you're having a number greater than 1, it's also wrong. You can't have your coefficient of friction greater than 1 or less than 0. Do you guys understand that now?
Yes, sir.
Okay. Others, are you mute? Unmute your mic and respond so I will know that you guys are here. Don't just keep quiet. Alright? So that's that about the coefficient of friction and frictional force, as it depends on the surface in contact. Now, another thing you should know about frictional force is that frictional force between two surfaces is independent of the area. If you like, have a body that is as big as this, the area of this body, so that you're going to get what I'm trying to say. Let me wipe this off. Let's take for instance that I have a body like this. Sorry, let me say I have a body like this, and I have that this body, the area is 5, the area of the body, okay, so let's say the area of this body is 10 meters square,
Um, so excuse, I have a question.
and I
So
have
if
another body. What's your question?
if the frictional force is not zero and it's not one, will the value of the coefficient be given?
You said
Like when you
what?
said if it's 0.5,
Yeah, stop
like you
that.
said if the coefficient of frictional force is when it is smooth is zero, then when it's rough is one. Then what of if it's between the rough and the smooth?
It's going
Like
to take any value between 0 and 1. I've explained that.
that's what I'm saying. Will it be given or are we to solve it?
They can ask you to solve for it. They can give you. If they ask you to solve for it, you should know that you can't have negative as your answer. You can't have what? A number greater than 1 as your answer. Your answer will always be less than 1 or equal to 1. Or your answer equal to 0. Your answer cannot be less than 0. It cannot be greater than 1. But it can be any value in between. And it can also equal to any of the two.
Okay.
So it's either you are given in the question or you are asked to calculate for it. Is that taken? Okay. So I'm about to explain how the frictional force does not depend on area of an object. So if the area of this particular body is 10 meters square and the area of this particular body is let's say 100 meters square. So sorry for the diagram, let me just increase it. Let me say this is it. So this one is kind of bigger than this. This one is 100 meters square, this one is 10 meters square. Now if I ask you to calculate for frictional force is given as coefficient of friction multiplied by mg. Do you see anything like area here? Do you see anything like area in this formula?
Yes, sir.
So since there is no area in this formula, all what frictional force depends on is the mass of this body. It depends on the mass. Are you getting it now? It depends on gravity. And it depends on coefficient of friction. That's what really determine what the value will be. So area of the surface in contact, either the area is big or it is small. It has nothing to do with frictional force. Frictional force is independent of the area. It's not dependent on the area. Okay? Another thing that frictional force depends on, it depends on the type of material which forms the surface which are in contact. The surface that are in contact, let's take for instance that you have this surface smooth and you have this surface rough. A smooth surface can be like a tiles, when you have a smooth tiles and you have what, a German floor, that is a floor that a concrete floor. Can they be of the same thing? You know, this one is made up of a concrete, this one is what, a smooth tiles. So this one that is a smooth tiles, the material that they use to make the smooth tiles is different from the material that they use to make what, the concrete floor. So because of the material that they use in making the tiles is said to be smooth. Because of the material that they use to make the concrete floor, the floor is said to be rough. So what makes this one smooth is the nature of the material. What makes this one rough is the nature of the material. And that is why we said frictional force is depending on the kind of material that you use to make a particular surface. Are we making sense now?
Yes, sir.
Frictional force depends on the weight of the material. Weight of the material is given as mg. And when you talk about normal reaction, frictional force is proportional to normal reaction. So if the normal reaction is I, it will affect frictional force also to be I, since frictional force is depending on the weight of the objects. Is that taken now?
Yes, sir.
Now when you talk about moving friction, there are two types of frictions. We have a static friction and we have dynamic friction. So you can call it dynamic or you call it sliding friction or kinetic friction, anyone. Now static friction, a friction that is the frictional force between two surfaces in contact. That is two static surface, a stationary body. For example, as you are sitting down and your leg is touching the floor, you are not moving. So the friction between your foot and the ground is static frictional force. But by the time you start moving, that static frictional force is going to be converted to what? Dynamic friction. So that's to tell you that dynamic friction, or what we call kinetic friction, is what you have when you are moving. The frictional force between your leg and the floor when you are moving is kinetic friction. So it's not possible for you to have the two happening simultaneously. When you have static friction, it means kinetic friction is zero. When you have kinetic friction, it means static friction is zero. Are you guys getting me now? It's not
Yes,
possible.
sir.
It's not possible for you. It's not possible for you to have both static friction and dynamic friction at a time simultaneously. Now let's look into that so that you are going to understand that very well. Now for static and dynamic friction, coefficient of static friction, let me give you an instance so that you understand. It's good if you can watch the video that I'm going to link with this on friction. I did better explanation on it there. I'm just trying to summarize here. Let's say that the weight of this object is given as mg and the mass is 10. The mass is 10 kilogram. So the mass of this object is 10 kilogram. And then the weight of the object acts in a downward direction. As the weight acts in downward direction from Newton's third law of motion, that downward direction in which the weight is acting is called what? Action. Then there is equal and opposite reaction, which we refer to as R, which is the normal. So if the gravity is what? 9.8, then the weight of this body is going to become 98 Newton. What you can also call the normal reaction also 98 Newton, because they are equal and opposite. So because the weight is equal to the normal reaction, that's why this body is not moving along the vertical axis. So the motion of this body along the vertical axis is zero, it's not moving. Now for you to be able to push this body, for you, let's take for instance that this is you and you want to push this body. For you to be able to push this body, you must be able to apply a force that can overcome the frictional force between this body and this surface. Because what is stopping this body from moving along the horizontal axis is the frictional force that is holding it. If there is no frictional force between the two surfaces, then the body is going to move freely. But as the body is not moving now, the frictional force is what is preventing it. Now, for a body that is not moving, we call the force, the frictional force, a static frictional force. And for a body that is moving, we call it kinetic frictional force. Are we together? Now, like I said earlier, it's not possible for you to have what? Static friction and dynamic friction simultaneously. If you're having static friction, then you don't have kinetic. If you're having kinetic, then you don't have static. Now, how do we determine the static frictional force between this surface? We need to know the coefficient of static friction. Now let's say the coefficient of static friction between this surface is given as 0.5, and we have that coefficient of kinetic friction is given as, let's say, 0.2. Now I want you to note something here, which is part of the properties of a friction. Coefficient of static friction is always greater than coefficient of kinetic friction. Please note that and know it. Coefficient of static friction is always greater than coefficient of kinetic friction. That is, a stationary friction is greater than a moving friction. Alright, so we have this to be kinetic friction, coefficient of kinetic friction. We have this to be coefficient of what? Static friction. Now the formula for static friction is given as F is less than or equal to coefficient of static friction multiplied by normal reaction. Why? This for static frictional force. Why for kinetic frictional force it is equal to coefficient of kinetic friction multiplied by the normal reaction, which is mg. Now I want you to note something here. Whenever you see something using inequality, please note, whenever they use inequality for an equation or a mathematical statement, what they are telling you is that that thing is not stable, it is variable. The value is not the same. There are some conditions determining its what? Its value. But when you see something that they use equal to, it is a constant. It doesn't change. Now, what does this mean? How does this affect what we are trying to explain here? What we are trying to tell you now is that static frictional force is not the same. It's not constant. It changes. But kinetic friction, no matter what, it is the same. It's constant. Guys, do you get those two statements clearly? Hello?
Yes, sir. Yes, sir.
Okay, maybe I should stop caring if you are hearing me or not. I can just carry on with my explanation. Because so that you guys are slowing a response, it's just dragging me back and it's tiring. So, get this and get this clear now. Static frictional force is not constant. It varies. Kinetic friction is constant. It will remain the same. That's why we use equality sign here and we use inequality sign here. Now, coefficient of static friction is greater than coefficient of kinetic friction. Now, for this body, the weight of the body is 98. Now, what will be the static frictional force? We have that the static frictional force is going to be less than or equal to 0.5. Let me do that calculation elsewhere so that I'll just write the value here. So that will be 0.5 times 98, and that will give us 49 Newton, right? So that means that the coefficient or the static frictional force is 49 Newton. What about kinetic frictional force? So kinetic frictional force is going to be 0.2 multiplied by 98. So if you have 0.2 multiplied by 98, that will give you 19.6 Newton. So now that you've known the static frictional force and you've known the kinetic frictional force, let's come back to this place now. So coming back to this place, you want to push this body to move. For you to push this body to move, you must be able at least overcome the static frictional force. If you apply a force that is slower than 49 Newton, this body will not move. But if you apply a force that is equal to 49, JAMB is so crazy that whenever they want to test you here, they will say, calculate the minimum force required. Minimum force required to make a body to move is what we refer to as limiting frictional force. When I say calculate the limiting frictional force, what the examiner is asking you is that calculate for the minimum force required to cause this body to move. And minimum force required is going to be equivalent to the static frictional force, because that's the only force that can cause this body to shake a bit. Though it will not cause it to move, but it will cause the body to want to move. Then, for kinetic friction, once you are able to push the body to move, then you don't need a force that is as high as this anymore. I get it that once the body starts moving, the kinetic frictional force will be what? 19.6. Now, I want to test you guys if you actually understand the essence of my noise, what I'm trying to explain here. Let me see if you are really getting the vibe. Let me give you a diagram like this. Let's say I have a straight line like this. Okay, so let this one be applied force. That is the force that we are applying on this body to push it. Let this one be the static frictional force. That is the force that is in between this body when it's not moving. And kinetic frictional force. That is the force preventing the body when it starts moving. And the net force. That is the total amount of force acting on this body. Let me try and buttress more on this net force. When you apply the force to this body to push it, the force you applied is acting on it. The frictional force is also acting on it. Your force is going in this direction. This is the applied force. Frictional force is coming in this direction. Are you getting it now? So it means you are having two bodies. This frictional force here acting on this body in this opposite direction. And you have normal reaction acting upward. You have what? The weight of the body acting downward. So the total force that is acting on this body is the summation of all these things. Fa plus R plus mg plus Fr. When you add everything together, that is the net force acting on this body. But you already see that at this vertical axis, the net force along the vertical axis is 0. Because when the body is acting upward, it is positive, that's 98. When the body is acting downward, it is negative, minus 98. That gives you what? 0. That means the net force along the vertical axis is 0. But along the horizontal axis, is it 0? We don't know. It depends on what? On the applied force. So if the applied force is going in this direction and frictional force is going in the opposite direction, you have what? Fa minus Fr. That will give you the net force. Am I making sense now? If the net force is 0, that means the body is not moving along the horizontal axis. And when the body is not moving along the horizontal axis, it's not moving along the vertical axis, that means the body is static. Now, we have seen the weight of this body to be 98 Newton. And the force that is affecting this body from moving is the static frictional force, which is 49. Now, class, if I apply the force of 10 Newton to this body, what will be the static frictional force? It's an open question. Can somebody respond, please? If I apply the force of 10 Newton, what will be the static frictional force? Is somebody responding?
It is 0, sir.
It's going to be 0.
Yes, sir.
Okay. Any other response?
No,
So I think it will still be
49.
49.
What?
Okay, it will still be 49. Okay,
Yeah, 49.
okay. Do you have any other answer?
So I'm taking is 39.
It's going to be 39. Okay. All right, we've all tried. Let me let you understand something here. If this force, if I apply force of 10 Newton to this body, and you said the static frictional force is 49, that means that 49 Newton force is pushing towards the left hand side, and 10 Newton force is pushing towards the right hand side. Are you getting it now? And you know that 49 is greater than what, 10. That means the body will move in this direction. It's going to move towards the, what's it called? It's going to move towards the left hand side. And you were told that for this body to move at all, you need to apply the force that is equivalent to the static friction. Now that the force that you applied is less than the static friction, can the body move?
No.
No.
So if the body did not move, that means this force is equal to this force. Am I making sense now? Because if this force is greater than this one, that means the body will move towards this side. Are you guys getting the explanation?
Yes, sir.
So static frictional force will not be work like that. Somebody saying something?
You come again with the explanation.
You were told that for you to let this body move, it required a minimum force that is equivalent to the static frictional force, which is 49 Newton. If you apply the force less than that, the body will not move. Now, and you are told that as you are applying force to this body to move towards the right, there is a frictional force also pushing the body towards the left. Now, if the applied force is 10 Newton, if the frictional force that is pushing the body towards the left is greater than that 10 Newton, that body will move towards the left. And you have been told that the body cannot move except the force that you apply is greater or equal to what? The static frictional force. Now, what will be the value of this force in order for the body to still remain at rest when you apply a force less than 49 Newton? Speak louder, I can't hear you.
59.
I think it's 10 Newton.
It's going to be 10 Newton, thank you.
10 Newton.
So because if this one is 10 Newton, if this one is 10 Newton and this one is 10 Newton, the body will still remain on a fixed position. Why? The net force here is going to be 0. So what will be the kinetic friction?
Zero.
0. Because it's 0 because we have said that when you have what? A static frictional force, it's not possible for you to have what? Kinetic frictional force. If you have static frictional force, that means kinetic frictional force is 0. If you have kinetic frictional force, that means static frictional force is 0. Then what will be the net force?
0.
0.
0.
Okay, let's move on. Let's see if you have understand more. Let's say I have a force of 30 Newton applied. What will be the static frictional force?
30.
30. What will be the kinetic friction?
0.
Zero.
What will be the net force?
0.
0. Okay. What if I have a force of 48.9 Newton? What will be the static frictional force?
48.9.
48.9. What will be the static kinetic frictional force?
0.
What will be the net force?
Zero.
Okay. What if I have a force of, let's say, 55 Newton? What will be the static frictional force?
6.
49.
When I have a force of 55 newton, what will be the static frictional force?
6.
49.
Oh God.
11.
6.
Is there no difference between
11.
static frictional force and net force? Why are you subtracting? Anything that makes you to have a force greater than the static frictional force, that means the body will start moving. And when the body start moving, static frictional force will become what?
0.
It will be
0.
zero. And what will be the kinetic frictional force?
55.
55.
It can't be
Yes.
55. You have been told that no matter the force you apply to the body, if the body is moving, kinetic frictional force is constant.
6.
What is the value?
19.
19.6. Are you guys getting this at all?
No.
What's there that you are not getting? You have been told that kinetic frictional force that is in between two surfaces, it remains constant. Once you calculate it, whatever value you have for it, that will be the value, no matter the force you are applying on it. Now you have applied a force of 55 newton, which is greater than the static frictional force preventing the body from moving. So if that should be the case, what will be the kinetic friction? Because static frictional force has become zero, what will be the kinetic friction?
19.6.
19.6 because it's constant.
19.6.
It should be 19.6 because that is the value you've calculated for it to be for this particular body. Now what will be the net force?
6, sir.
The net force will be what?
6.
It can't be 6. Because right now, the net force will now be, okay, you have applied a force of 55 newton going like this. And you have applied what? A frictional force is applying a force of what? 19.6 newton. So what will be the net force?
35.4 Newton.
35 point
4.
35.4. Okay, let's see again. Let's see again. If you have really understand, let me know. Let's say if I have a force of 50 newton, a force of 50 newton, what will be the static frictional force?
0.
0.
What will be the kinetic frictional force?
19.6.
19.6.
What will be the static the net force?
Times
30.4.
30.
30.4. So do you understand this now?
Sir, please, I don't understand.
What's there that you don't still
From
understand? Is your mind in this
from
class?
the first, so I'm listening, but I don't understand. Please, can you just go back to it again? From the force of apply and the fictional force.
Here it is. You have a body resting on a platform, and the weight of this body is given as 98 newton, and you have the normal reaction to also be the same. Now you want to push the body to move. In order for this body to move, you must be able to apply a force that is greater than the static frictional force. Because when this body is at rest like this, the force that is preventing it from moving is the static frictional force. If you want to let the body move, then you must apply the force greater than the static frictional force. If the force is less than the static frictional force, the body will not move. Now, if you are applying force in this direction, if you are applying force in this direction, this is an applied force. Frictional force is going to be applying in this direction. Are you following now? Applied force towards the right, frictional force towards the left. Now, how do I know the static frictional force here? The static frictional force is less than or equal to coefficient of static friction multiplied by the normal reaction mg, and the kinetic friction is equal to coefficient of kinetic friction multiplied by the normal reaction, which is mg also. Now, let's take for instance that coefficient of static friction is 0.5 and coefficient of kinetic friction is 0.2. Coefficient of kinetic friction is always less than coefficient of static friction. If this is the case, that means that static frictional force is less than or equal to 49. That is 0.5 multiplied by 98. And you have that kinetic frictional force is equal to 19.6. That is 0.2 multiplied by 98. Now, what does this value mean? This value means that static frictional force, that is the force preventing this body from moving, is 49. If you want this body to move, you have to apply the force greater than or equal to this particular force. If the force is less than this force, the body will not move. If the body did not move, that means the applied force is the same thing as the frictional force. And since the body is not moving, that frictional force is going to be static. Now, if you are able to apply the force greater than this 49, that means the body will move. If the body moves, that means static frictional force has become 0. Because when the body starts moving, the frictional force the body will have is kinetic frictional force. And it's constant. It doesn't change its value, except you change the subjects that you are using. The value remains constant. Am I making sense? So if that should be the case, that means by the time this body starts moving, the applied force is already greater than 49. Therefore, static frictional force will be 0 and the kinetic frictional force will remain the same. So for you now to get your net force, you take away the applied force from the frictional force. The frictional force away from the applied force. When they are the same thing, that means the net force is 0. When they are not the same thing, that means you are going to have a net force. Are you getting it now? So if that should be the case, if I apply what and I have this now, I have this. So if I have this now, this is going to be applied force. This is static frictional force. This is kinetic frictional force. This is net force. If I apply the force of 30 Newton to this body, where will be the static frictional force?
0.
30.
It's going to be 30. Why will it be 0? If it is 0, that means this body will move.
Don't forget.
So this 30, what will be the kinetic frictional force?
0.
0.
Is 0. What will be the net force?
Nothing.
0.
0.
Okay. Then if I have the force to be 40 Newton, what will be the static frictional force?
40.
What will be the kinetic frictional force?
0.
No, 0.
What will be the net force?
0.
If I have the applied force to be 50 Newton, what will be the static frictional force?
0.
What will be the kinetic frictional force?
19.6.
19.6.
19.6. What will be the what? Net force?
So
30.4.
34 point.
34.5?
30 point, no, 30.4.
30.4. Okay,
4.
thank you. 30.4. Okay, if the applied force is 55 Newton, what will be the static frictional force?
0.
0.
It's going to be 0.
0.
The kinetic frictional force,
19.6.
19.6.
the net force.
35.4.
35 point.
So do you understand this now?
Yes, sir.
That's to tell you that static frictional force is depending on the applied force, while kinetic friction is independent of applied force. You can see that the applied force is just what determines the value of static frictional force. Are you seeing that?
Yes, sir.
Yes.
But if you look at the kinetic friction, does it determine the value?
No.
So you should note that static frictional force depends on the applied force. Kinetic frictional force is independent of the applied force. These are properties that examiner want to use to test you as far as friction is concerned. Do you understand that now?
Yes.
Now, let us move to advantage and disadvantages of friction. So we have talked about the properties of friction now. Let's look at advantage and disadvantage of friction. Now, when we talk about advantage and disadvantages of friction, what does it mean? What it implies is that in which way or in which of the following is friction a positive thing that is needed? Let me reconstruct my English so that you get it what I'm saying clearly. When I say advantage of friction, they are trying to ask you that where is friction useful? That is, if friction is not there, we are not going to achieve what we are supposed to. Then when I say disadvantage of friction, what they are simply asking you is that where can we have friction that is going to prevent us from having what we're supposed to have? So when friction becomes an obstacle, it is disadvantage. When friction becomes what? Becomes positive, that is something that enables us to achieve, it becomes advantage. So now look within yourself and ask yourself, where do we have friction to be advantage, and where do we have it to be disadvantage? I'm asking now.
Advantage where we work.
When we work,
Disadvantage
okay,
for the break off.
the frictional force between the brakes and the wheels is positive, abi? That's what enable the brake to be able to work. If there is no frictional force between the brake and the wheel, when you apply brake, then the car will not stop. And when the car did not stop, you know what will happen? Frictional force between the brakes and the wheel. Okay, we have that the frictional force between the tires and the surface of the ground of the vehicle. The frictional force between the surface, between the tire, let me put it like that, between the tires and the surface on which the vehicle is moving. The frictional force between the belts and pulley. The frictional force between the belt and pulley of a machine enable the machine parts to move. Enable the machine parts, enable the machine parts, enable the machine parts to move. What I wrote here is not correct. Follow what I said. The frictional force between the belt and pulley of the machine enable the machine parts to move. Also, the nail is able to hold wood together, because of friction. You can move without slipping. Because of friction. etc. So these are some of the advantages of friction. Do you guys understand this now?
Yes, sir.
Yes.
Now let us look at disadvantages of friction now, where friction becomes disadvantage. Because you need to note all this very well. That's the reason why I explained what is advantage and what is disadvantage to you earlier. Because it's not really possible for me to give you all the whole cases where friction is advantage and all the whole cases where friction is disadvantage. I can only list but few. Am I making sense now? So, but when you understand what makes things to be advantage and what makes things to be disadvantage, then you will be able to identify where it is advantage and where it is disadvantage. Alright? So, which one thing for disadvantage? It causes what? The wear and tear of engine. The wear and tear of engine. Sorry. It causes the wear and tear of engine. So that is what makes you to start changing parts of your machine. You know, when you start using your machine, with time they tell you that, oh, this shaft has stopped, you have to remove it. This one, what causes those things is what? Why you need replacement is as a result of friction. That's what I mean by what? Wear and tear of machine. Then it causes overheating of engine. It causes overheating of engine. Many of us will have experienced this before. You don't see a car on highway park opening their bonnet. Is as a result of what? Overheating. It reduces efficiency. Efficiency of machine. So we said it in the last class that machine cannot work 100% efficient. Why machine cannot work 100% efficient is because mechanical advantage is less than velocity ratio. What makes mechanical advantage less than velocity ratio? was because what? Mechanical advantage is being affected by friction. So friction reduces what? Efficiency of machine, it causes overheating of engine, it causes wear and tear of engine. Do you understand that now? So all of
Yes.
these are disadvantages of friction. Alright, so the next one is that, okay, now that we have understand the advantage and disadvantage of friction, in a case where we don't need it, that is going to result to disadvantage, what can we do? Can we remove it completely? Can we reduce it? Are you getting it now? So that is where this particular one comes. How to reduce what? Friction. Are you getting it now? Because in a case whereby you have excess friction, there is need for you to reduce it. Are you getting it now? In order for that thing to be useful or for you to be able to carry out your operation, there is a need for you to reduce friction. So part of the method of reducing friction including polishing. Why polishing? When you have a rough surface always increases friction. That's why when you have a rusting bolt, a bolt that has rust and not, it will be difficult for you to lose it. So in order for you to what? To reduce the friction, if you can polish it so that you have what? A shiny surface. A shiny surface always smooth. Are you getting it now? So friction is going to reduce. Also, banking. Banking is the method of reducing sideways friction. Method of reducing what? Sideways friction. For example, if you have a bike man that wants to turn around what? A roundabout. And you must have seen those bike men before trying to use their bike to write zero. For them not to fall, what will prevent them from falling down is what we refer to as banking. Because if the frictional force there is high, the body will not be able to rotate freely. Not being able to rotate freely can cause the objects to fall, which is going to bring about accidents. In that case, there is need for you to maintain the friction. For you to maintain the friction, you need to understand the banking angle, which is the method of reducing the friction. When we go to calculation, I'm going to be showing us how to get what? The value for the banking angle. Alright? So another one is the grease. Or if you don't want to call it grease, you can call it lubricant. The lubricant method. You see, the lubricant method including grease, oil. I get it now. Grease and oil, they are under the lubricant method. But what determines the one that is perfectly to use? What determines the one that is perfect to use and the one that can really reduce the friction is how viscous they are. Are you getting this now? That their viscosity is what determines if they can reduce friction or not. Otherwise, we would have said petrol, we would have said kerosene. Those ones are also liquid. Are you getting it now? But the reason why we can't use petrol or kerosene or water is because of their viscosity. They are too light. They are not thick at all. That's why we can't use them. So when you say lubricant method, you are talking about a liquid that is viscous. Am I making sense now? If you look at grease is semi-solid. It is liquid, it is like a liquid, and it's also like a solid. So what makes it look like a solid is because of its viscosity. Oil is thick, but at the same time it can flow. Are you getting it now? Because of its level of what? Viscosity. What we can use what? Oil, that is engine oil. What we can use it to reduce your friction. We can also use what? Palm oil to also reduce your friction. Are you getting it now? Why? because of their level of viscosity. But palm oil will reduce friction better than groundnut oil. I get it because it's not viscous compared to groundnut oil. But engine oil will reduce friction than palm oil than groundnut oil. Why? Because it's more viscous than them. Then grease will reduce friction more than palm oil, more than groundnut oil, more than engine oil because it's more viscous. Alright? So another method of reducing friction is what we call streamlining. So when we talk about streamlining method of reducing friction, what does it mean? Streamlining simply means building an object. Hello, are we together, guys?
Yes, sir.
When you build an object in a way that it is partially in contact with air, when you build an object that it is partially in contact with air, that's what we call streamlining. For example, if you look at your airplane, it has a sharp mouth. This sharp mouth is what makes the number of air that is in contact with airplane, that's what makes it reduce. When you look at your canoe or your ship or your boat, you see them like this. Why are they having these sharp edges? It's because of what? Streamlining, so that they will have less contact with air. Or let me just say fluid. Am I making sense? You know, when I say fluid, you talk about liquid and then gas. That will refer to as fluid. So streamlining is like a method of reducing what? A fluid friction. Is there anybody that doesn't understand this? Do you understand the method of reducing friction?
Yes,
Yes,
sir.
sir.
Is that what?
Yes, sir.
Yeah.
All right.
Yes, sir.
All right. Thank you. Now let me give you the last one. This last one, some of you usually do it, but you don't know that that is what you are doing. You don't know you are reducing friction. For example, those of you that always put on a pencil jean, you know what they call pencil jean, right? Those jeans that their mouth is always very tight. Some of you, it will be so tight that you find it difficult. You find it what? Difficult to put your leg inside. Why are you finding it difficult to put your leg inside? Is as a result because that thing did not enter your leg. Because not entering your leg has increased the friction. So that's why you see some people, for them to be able to wear it, what they will do is that they are going to put nylon in their leg. So putting nylon in their leg will reduce what? Friction. It will enable you to be able to put on the trouser easily or pull the trouser easily. That is what we call polythene. Do you understand that now? That's another method of reducing friction. So guys, do you understand this now?
Yes, sir.
Yes, sir.
Okay?
Yes.
So, by now, we can now move on to the calculation part of it, which is going to be the last part to be considered on this topic. So before I move to that last part, I want you to please and please, I won't be proving any equation here. If you want to see the proof of all these equations that I'll be using here, kindly check what is it called? Kindly check the video that I'm going to link under this lecture. So that is a complete lecture for friction, and then I do a lot of proving and explanations there. Now, if you want to calculate for frictional force, that is, you are given a body that is resting on a table, and you are asked to find what? Anything about the body. Maybe the weight of the body, the normal reaction, or the frictional force of the body. That's it. So how do you go about that? Let's start with this. Let's say I have a platform like this. This is a surface, and on this surface I have an object here of mass m. This object of mass m is exerting a force in a downward direction that makes the weight to be mg, and in the upward direction you have the normal reaction r. Now you might be reading some textbooks and you are going to see normal reaction. Instead of using r, they will call it Fn, F sub n, to be the normal reaction. Whichever one, this is the applied force F, and then you have a frictional force acting in opposite direction. This frictional force, the frictional force is proportional to the normal reaction R. If I remove this proportionality sign, I will have that frictional force that can either be static or kinetic to equal to what's it called? The frictional force will then equal to mu multiplied by r. That is equation 1. So frictional force is proportional, is equal to coefficient of friction times normal reaction. So if r is equal to mg, then you have that static frictional force, sorry, frictional force is equal to coefficient of friction multiplied by mg. So also you can say coefficient of friction is equal to force over normal reaction. So since force is measured in Newton, reaction is also measured in Newton. Newton will cancel Newton. That's why the coefficient of friction is not having a unit. Alright, so if that should be the case also, you can also say coefficient of friction is F all over mg. So note all these equations, they are very, very important. Now, let's go on by coming down to this point here. Let's say I want to consider a kinetic friction in motion. Then for me to be able to do that, I can say kinetic energy is equal to work done. Since energy is the same thing as work done, in some cases, in most cases, let me just put it like that, energy is the same thing as work done, and I think we have explained it before in this class. Alright, so kinetic friction is given as 1 over 2 mv square, and the work done is given as force times distance. Now let's say that this force that we have here is the frictional force. So the frictional force is going to become mv square divided by 2s, which is another equation for frictional force. Okay, so let me just call this star. So all these equations, we use them to calculate for frictional force and whatever related to them. Alright, so if this should be the case now, let us now consider a friction on an inclined plane. So when you think about friction on an inclined plane, what does it mean? Inclined plane is a machine. It's an example of what? Machine, and I think we'll talk about that in the last class. So if you have not watched the lecture, kindly go and watch it. Now let's say here is theta, which is angle of inclination. If I have an object of mass m acting on this surface, this force here is applied force, or you can call it a force of gravity, or force of gravity plus applied force. Like I said, I don't want to do a lot of proving here. If you want to know how the proving of all of this will, you can check the link below and watch the video. So this one is going to move downward like this. So if it's moving downward like this, because it's moving downward, a force is what? Opposing the motion, which is the frictional force. Now for you to be able to get this frictional force, we therefore have that frictional force is equal to, let me put it like this, I think this will be better. Coefficient of friction is equal to, the applied force of frictional force is given as mg sine of theta, and the normal reaction is given as mg cos theta. I've explained how we come about all of this in the last class, in the link below. So coefficient of friction is going to be F all over R, and that will be mg sine theta divided by mg cos theta. So mg will cancel mg. You therefore have coefficient of friction to be tangent of theta. So we have this now. This coefficient of friction, tangent of theta. Okay guys, so what else can we do? Under this equation, we are saying that F is mg sin theta, R is mg cos theta, coefficient of friction is tan theta. So guys, I want you to pay attention. JAMB can be so crazy. When they give you angle and you are asked to look for what? The coefficient of friction. Don't stress yourself. Just know that coefficient of friction is the same thing as tangent of theta. Is that clear?
Yes, sir.
Yes, sir.
Alright, thank you. Now, let's take for instance, which is going to be the last part of what I'm going to discuss here. Normally, there's an aspect of force of friction and acceleration. So please watch the video to really see how to calculate for acceleration of a body on an inclined plane and the conditions that bind it when you are pushing the body upward and when you are pushing the body downward. So watch the video to learn more about that. Now let's take for instance that I have a body like this and a man is driving a bike. At what angle will this man place the bike so that the bike will not fall? By moving round this roundabout. The first thing you need to ask yourself is that what force produces the centripetal force? Remember, we've once discussed this before under our circular motion class. If you have not watched it, you can watch it. I'm going to drop the playlist of all our classes. I'll drop it on the group by the end of the class today, so that for those that just join and those that they are not just joining but they need some lectures, you can watch everything there. Okay? Now, when you say centripetal force, for every body that is moving in a circular orbit, there is a centripetal force that keep the object on track. That centripetal force is being produced by different applied force depending on the case you have at hand. At times, it can be produced by gravitational force. It can be produced by tension force. It can be produced by frictional force, as the case may be. Now, if this body is moving around this roundabout, what is somebody saying something? Is somebody saying something?
No, sir.
Okay, thank you. So, right now, if the body is moving around this roundabout, that means that the centripetal force is equivalent to the frictional force. So, if centripetal force is equivalent to the frictional force, I have that frictional force is given as coefficient of friction multiplied by mass times gravity. And this is equal to centripetal force, which is equal to 1/2 mv squared. So m and m will cancel. You therefore have that coefficient of friction is equal to v squared all over 2g when you divide both sides by g. So coefficient of friction mu, remember we are looking for the angle that the man is going to place the bike. Coefficient of friction is now going to become the tangent of theta to equal to v squared all over 2g. You therefore have that theta is arctan of v squared all over 2g. So whatever result you have here is going to be the banking angle. Okay? So that's about frictional force, and I want to believe that you all understand this. But before I call it a day or late, I want you to understand that whenever you are placing a body on an inclined plane, because that's the question that examiners always want to ask here theoretically, that is, what are the factors that a body on an inclined plane, what are the factors that it depends on? I want you to understand that the body on an inclined plane is independent of the mass. No matter the mass of the object that you place on an inclined plane, it will slip at the same rate irrespective of their mass. What determines the acceleration of a body on an inclined plane is the angle of inclination. So if the angle is high, the body tends to slip very well. It will become more slopey. If the angle is low, it will not be more slopey. And when it is not slopey, the body will not be able to slip easily. Okay? I believe you understand that now.
Sir.
Is that what?
Yes, sir.
Okay, so let's take a look at some questions under the topic friction. So we can get our JAMB pack now. But before we start looking at our JAMB pack for more questions, let us answer the questions that take us down to this place. Okay, so let's look at the question now. So the right answer to this question: which of the following could be effectively used to reduce friction?
Greece.
Grace.
So the correct answer is
Grace.
grease. Thank you. So I believe that is clear now. Okay, so let's just look at few questions before we call it a day on this topic. Now, I want you to open your ear very well because I might not be writing the question, I might just dictate it because of time and my laziness. So, because of time and my laziness, I might just dictate the question without writing it, but I'll try to write the option. So please open your ear and pay attention. The question states that the friction which operates the friction which operates when one solid surface the friction which operates when one solid surface slides over another is called a
And Peter, start going to your house.
is that what? It's called solid friction, B static friction, C limiting friction,
Me, I know they go. How are you?
D dynamic friction, and E none of the above. So what's the right answer to that question?
Dynamic friction.
Dynamic friction.
Dynamic friction. So do you understand that now? So when the body is moving, the frictional force is going to be dynamic. So in a case, if you look at this now, static friction and limiting friction, they are almost the same thing. They are almost the same thing. Is that taken now? Because limiting friction is equal to static frictional force. That is, if the static frictional force is, let's say, 49 Newton like we did in class, limiting frictional force would also be what? 49 Newton. Alright? Okay, so another question here states that I think this one is 1979 question number 3. JAMB 1979 question number 3. The question says, which of the following statements is not true of friction between two solid surfaces? Which of the following statements is not true of friction between two solid surfaces? A. Option A, the frictional force between two solid surfaces is greater when one object 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 is moving than when they are both at rest. Than when they are both at rest. Option B, the frictional force between two rough surfaces is greater than that between two smooth surfaces. The frictional force between two rough surfaces is greater than that between two smooth surfaces. Option C, the frictional force between two surfaces is independent of the area in contact. The frictional force between two surfaces is independent of the area in contact. Option D, frictional force depends on the type of material which forms the surfaces which are in contact. Frictional force depends on the type of material which forms the surfaces in contact. And E, frictional force is proportional to the normal reactions on the surface. So the question is, which of the following statement is not true?
A.
Okay. So any other answer aside from that? Do you have a contrary answer? Okay. So everybody go with A, right?
Yes, sir.
So the correct answer there is what? Is A, because the coefficient of static friction is greater than coefficient of kinetic friction. So frictional force when the body is at rest is greater than frictional force when the body is moving. So that's the correct answer. A is the right answer there. So it's wrong. It's not true. The statement is not true. Okay, let's take another question. Okay. So alright, so let's take this one on. This next question here. The question here states that 1995 question number 13. 1995 question number 13. Question: which of the following statements are true about frictional force? Which of the following statements are true about frictional force? Roman figure 1, it is always a disadvantage. It is always a disadvantage. Roman figure 2, it is sometimes a disadvantage. It is sometimes a disadvantage. Roman figure 3, it always exists. It always exists. It always exists where there is a relative motion. It is always exists where there is a relative motion of two bodies. Relative motion of two bodies that are in contact. Roman figure 4. It is sometimes very useful. It is sometimes very useful. So the question says, sir, which of the following statements are true about frictional force? So option A, Roman figure 1 and 2. Option B, Roman figure 1 and 4. Option C, Roman figure 2 and 3. Option D, Roman figure 2 and 4. So which one is correct?
3 and
4.
Is that what?
Roman figure 2 and 4.
Roman figure 2 and 4. It is sometimes a disadvantage. It is sometimes very useful. So that's the correct answer, the Roman figure 2 and 4. Thank you. Thank you for that. Okay, so let's see another one. Okay. Okay, so this one is going to be the last one we're looking at under the theoretical part, and I'll urge you to try as much as you can to solve more questions on it before we go to calculation. So the question here states that it's year 2013 number 11. Year 2013 number 11. The question states that the coefficient of friction between two perfectly smooth surfaces is A 1, B half, C 0, D infinity.
0.
0. So the correct answer is what? 0. That's awesome. Okay. So now let's move a little bit down to calculation, and let's see how far we can try on that. So the question here states that this 1998 question number 4. We have this diagram there. Okay. Oh, anyhow, so let me just draw it roughly. Okay. So I have this, and I have this to be a spring balance. And here is an applied force. So the spring balance goes in this direction, and here I have the weight of the object to be 25 Newton. So the question states that in the above diagram, in the above diagram, the block just moves. The block just moves when the spring balance, the block just moves when the spring balance reads 15 Newton. The block just moves when the spring balance reads 15 Newton. What is F? What is F? A 0.6 Newton, B 10.0 Newton, C 15.0 Newton, D 40.0 Newton, and E 375.0 Newton. So which one will be the right answer, guys?
C.
So what will be the right answer there?
C.
C, right? So thank you so much for that. That shows that we have really understand that, because that means they are talking about the limiting frictional force, and that's just a force that is sufficient to what, to allow the body to start moving. Okay, so thank you. So the correct answer there is going to be 15 Newton. No need for any calculation. That's the essence of the first drill that we did in the class, when we are talking about static friction, kinetic friction, and so on like that. So, all right. Okay, this one is 2009, number 11. The question states that of mass, an object of mass 80 kilogram is pulled, an object of mass 80 kilogram is pulled on a horizontal, rough ground, on a horizontal rough ground by a force, of 500 Newton. So the question states that find the coefficients of static friction. Find the coefficient of static friction if G is 10 meter per second square. Option A, you have 0.8. Option B, 0.4. Option C, 1.0. Option D, 0.6. So what are our right answer, guys?
0.6.
0.6. So
Zero
that
point six.
so that's correct answer there. Is there anybody that doesn't know how to solve this? Okay.
Sir,
Is that what?
I do not how she got it.
Okay. An object of mass 80 kilogram. The mass of the object is 80 kilogram. Is pulled on a horizontal rough ground by a force of 500 Newton. So the force is given as 500 Newton. Find the coefficient of static friction. So we are looking for coefficient of static friction if G is equal to 10 meter per second square. So how do you go about this? Coefficient of static friction is given as F all over R, and R is given as mg. Abi? So the force is what? 500. So you have 500 divided by mg. That will be 80 times g. That is 80 times 10, and that will give us 800.
100.
So 5 divided by 8, that will give us 0.625. Is it clear now?
Yes.
Yes.
Okay. Alright, so 1981 question number 9. What says the time now? Okay, we have 2 minutes more. We have 2 minutes more. Okay. Alright, so this question here states that a child A child pulls a toy car, weighing pulls a toy car weighing 3.00 kilogram along a cement floor. If G is 10.0 meter per second square and the coefficient of friction is 0.500, the minimum force required to move the car is A 3.0 Newton, B 5.0 Newton, C 10.0 Newton, D 15.0 Newton, E 60.0 Newton.
C.
The answer is what?
15.0 Newton.
So 15.0 Newton. So the correct answer is D. Okay, thank you. Alright, so before we move on, let's look at this also. Thank you so much. I hope everybody understand how we get that.
Yes.
Alright. Okay, so we'll look at this one now. This one is like a question on an inclined plane. Okay, so we have this. I have this diagram. Please, I will only read out the question because of time, and I will write down the options. So I have here to be theta, and here is an object, and this is the weight W. So the question states that the figure shows a block of wood of weight W just on the point of sliding down on a rough plane, inclined at an angle theta to the horizontal. What is the coefficient of friction between the block and the plane? Option A, W tan theta. Option B, tan theta. Option C, W cos theta. Option D, W sin theta. And option E, cos theta. So which one is the right answer there? Oh, I should take the question again.
Sin theta.
You saw what?
W sin theta.
W tan theta.
Yes.
Sin theta.
The question says, what is the coefficient of friction?
Tan theta.
W tan theta.
You saw what?
W sin
W
theta.
tan theta.
Somebody said W tan theta, right?
Yes.
Is that what we all say? Do you all agree to that?
W sin theta.
Another person said W sin theta.
Tan
And I
theta.
said D. Tan theta.
So the correct answer is tan theta. You have been told, no matter the old story they want to tell you, it doesn't change. that coefficient of friction on an inclined plane is given as tangent of theta. So it is the normal reaction R that is given as W cos theta. It is the frictional force that is given as W sin theta. Is that taken now?
Yes.
Yes.
So coefficient of friction is always tangent of theta. Alright? So let's move to the next question. 1982 question 14. 1982 question number 14. Okay? So here we have a weight of 50 Newton. And from here to this place we have 5 centimeter. From here to this place we have 25 centimeter. And here is angle theta. So the question states that the diagram shows a block. The diagram shows a block of wood. The diagram shows a block of wood resting on an inclined plane. And at the point of sliding down the plane, calculate the coefficient of friction between the block and the plane. I'll tell you the question again. The diagram shows a block of wood resting on an inclined plane, and at the point of sliding down the plane, calculate the coefficient of friction between the block and the plane. A is 0.1, A 0.1, B 0.2, C 0.3, D 0.4, E 0.5. So which one is the right answer there?
B 0.2.
Is that what?
Is D.
0.2.
Somebody says 0.2. Is that what we all said?
0.5.
Is that what?
No. 0.5.
Okay, we are having two answers here, 0.2, 0.5. Okay, so since we are looking for coefficient of friction, we have that the tangent of theta is opposite, which is 5 centimeter, over adjacent, which is 25 centimeter. So this and this would cancel. 5 here 1, 5 here is what? 5. So we have that the tangent of theta is going to be 1 all over 5. So convert 1 over 5 to fraction. You multiply both numerator and denominator by 2. And you have the tangent of theta to be 2 over 10, which is 0.2. So the person that choose 0.2 is correct. So you that choose 0.5, what's your mistake? Hello, are you there?
Why did you multiply it by 2?
You can as well press your calculator for 1 over 5. You have your result. I only multiply by 2 so that I can convert it to fraction easily.
Okay.
Alright, so can we go on?
Yes, sir.
Okay, let's take another one, yeah? Okay, so the question here states that if I have this,
Okay.
and this is a block, and here is alpha. The question says the diagram above shows a wooden block just about to slide down on an inclined plane, whose inclination to the horizontal is alpha. The coefficient of frictional force between the block and the plane is A sine of alpha, B, tan of alpha, C, cot of alpha, and D, cos of alpha. Which one will be the right answer?
B.
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 The answer is what? B.
Alpha.
B.
Thank
Tan
you.
of alpha.
Okay, so let's take this to be our final answer, our final question for today. Okay, so the question states that
Mhm.
a load is pulled. A load is pulled at a uniform. A load is pulled at a uniform speed along a horizontal force, along a horizontal floor rather, by a rope, at 45 degree to floor. If the force if the force in the rope is 1500 Newton,
The 45 is 1.
what is the frictional force? What is the frictional force on the load? What is the frictional force on the load? So calculate now. A, 1542 Newton. B, 1350 Newton. C, 1260 Newton. And D, 1061 Newton. So what's the right answer there?
D.
B, 1350 Newton.
D.
Okay, you said D, 1061 Newton. Okay, it's an answer. Let's wait for us. Do you have any answer that contradicts that? Is that what? Okay, we all said D, right? Okay, so that's correct. Is there anybody that doesn't understand how to get D?
Yes, sir.
Okay, you don't understand how to get the D.
Yes.
Okay, so let's read the question together and see. Who is that musician? Please, you can mute your mic before you sing. Now the question states that a load is pulled at a uniform speed along the horizontal floor. Let's say this is an horizontal floor. Okay, by a rope at 45 degree. So let's say this is the road, here that you are pulling. This is the load, and then the rope is at an angle of what is it called? At an angle of 45 degree. So this is 45 degree. So what's the next thing? So frictional force is acting in this direction as you pull the load towards this direction. So the force you apply, if the force in the rope is 1500, so the force in this rope is 1500 Newton. What is the frictional force on the load? So we are looking for frictional force, which is going to be an horizontal force here. So the horizontal force, frictional force, is going to be mg sine of theta. Are we together now? Sorry, we are looking for the one below, right? So that's supposed to be mg cos of theta. Because if you look at this now, this is opposite, right? And this is what? Adjacent. This is hypotenuse. So if I'm looking for this one, which is the adjacent, I will have that cos. Sorry.
adjacent hypotenuse.
So this will be cos 45 is adjacent, which is the frictional force, over hypotenuse, which is 1500. So when you cross multiply, you have the force to become 1500 cos 45, and that will just give us 1601 Newton. Is that okay now?
Yes, sir.
Alright, so this will be a good place for us to stop, and in the next class we just continue from the next question, which is question number 14, if I'm not mistaken. Alright, so try as much as you can. Go through the questions drop on the group, that is the landed physics that we have on the group, and try to solve some questions on it. Is that taken now? So, see you guys in the next class.
We're waiting for you off